What in the world is this giant circular flow diagram? Good gracious, look how much activity is taking place on this one diagram. It looks like a far cry from our simple circular flow model introduced in chapter 1. But really, it's just a more in-depth investigation into the economic activity taking place within the country. Now, remember, what is the title and purpose of this chapter? National income accounting, also known as studying gross domestic product, how much economic activity takes place within the nation. And the reason behind studying economic activity, or GDP, is to measure it, to compare GDP this quarter or this year to recent activity and historical changes, or historical trends, I should say, and then, if necessary, make policy changes. So we measure economic activity, we compare, and then, if necessary, we make changes to fiscal and monetary policy. So, what is GDP? It's a monetary measure of all final goods and services produced within the domestic borders of the United States in a given year. Sorry to rush through that, but it's about the 100th time I've said this in an online video, so you should all be familiar with the definition and understanding of GDP to begin with. But it is a measure of how much a country is producing. So remember, we can either add up all the money that's spent on final goods and services, or the income generated from producing those same goods and services. Let's think logically here and say, okay, the 4 rectangular boxes. On the far right we have households, in the middle we have government, a little bit further left we have businesses, and up top on the left we have all other countries. So that's C plus G plus I plus X, not in the proper order, but it's U.S. households is consumer spending, U.S. government is government spending, U.S. businesses is gross business investment, and all other countries is net exports. So we can add up all the money that's spent on final goods and services. Notice that the spending outflows from each of those rectangles flows into the GDP rectangle, the nice large green rectangle labeled gross domestic product. Now, of course, it's net exports, so it's actually C plus I plus G minus X. But this helps us visualize, okay, we can either add up all the money that's spent on final goods and services, or add up the income generated in producing those same goods and services. So notice the other side of the rectangle is the same amount, right? Compensation to employees, rents, interest, dividends, proprietors' income, corporate income taxes, undistributed corporate profits, taxes on production, and consumption of fixed capital. So we said we can also add up all the income generated from producing those goods and services with some statistical adjustments. It comes out to the same number as GDP. Okay, what about NDP, net domestic product? Well, that is what? How much the economy can produce and consume without impairing our ability to produce in the future. So notice, if we just take gross domestic product and we subtract consumption of fixed capital, remember consumption of fixed capital also means depreciation. So we take all the goods and services produced in the United States minus the amount of machines and equipment it took to produce those services, the machines that were worn out or used up because of what we call depreciation, and that gives you net domestic product, right? Net national income, the next rectangle to the right, right? How productive are American-owned resources, whether here in the good old US of A or somewhere else in the nation or in the world? So national income, and then personal income, income that is earned but not necessarily received, and income that is received but not necessarily earned. Whoa, that's a lot to say, but the most important one is disposable income. When it's all said and done, the economy produces a lot of goods and services. People get paid in the form of wages. Land receives rent. Capital receives interest. Entrepreneurs receive profits if successful. And after taxes, right, we have disposable income. And disposable income is what is left for next year's spending. So this circular flow diagram is a good way to sort of review everything we've learned up to this point about the chapter on national income, accounting, and gross domestic product. Okay, now GDP equals P times Q. This is one of the first equations we introduced at the beginning of this chapter on gross domestic product, national income accounting, and economic activity. So we are measuring the quantity of goods and services produced within the domestic borders of the United States in a year. We're measuring Q, but as we said earlier, GDP is a monetary measure, so we need the prices of those goods and services to make sense of the economic activity. We can't just say, 7,800 townhomes were built and 100 million, packs of gummy bears were sold last year, right? We need price as the common denominator. So we're measuring Q, but we use P to sort of add it all up here. So GDP equals P times Q. However, we have a little issue. Let's look at some numbers. GDP for 2010 was $10 trillion. GDP for 2011 was $11 trillion. If I asked you, in percentage terms, how much did the economy grow between 2010 and 2011? Now, just as a note, these aren't the actual numbers. I just used these numbers to prove a point to teach this lesson to econ students. But let's assume for a moment these are the numbers. So the numbers are reported. 2010 economic output GDP is 10 trillion. 2011 economic production is 11 trillion. Well, it appears that the economy grew by 10%. How did I get that? Well, you take the 11, which is 1 more than 10, right? You say, okay, so 1 over 10 is 10%, right? But here's the problem. Between 2010 and 2011, the cost of many goods and services is increasing. So we're trying to measure Q. At the same time, we know that P is changing in value. Okay? So if we ask in percentage terms how much did gross domestic product grow, we may falsely come to the conclusion that that over this 1 year period it grew at 10%. But what if prices were increasing by 7%? Then the economy didn't really grow by 10%, it only grew by 3%. So what we have to do is we have to figure out a way to avoid this incorrect assumption of 10% by looking at what economists call the nominal numbers, nominal GDP. So GDP equals P times Q. Notice the triangle around the P variable for prices of goods and services. Triangle is what? It's the symbol meaning delta or change. It's Greek symbol meaning delta or change. And we use this to signify that the prices of goods and services changes over time. Typically, we have what is referred to as inflation, a slight increase in the prices of goods and services. Matter of fact, since 1950, the United States has never actually experienced a year of deflation, where the general price level or the average price level in the economy was falling. But this is quite possible, even in a modern industrialized country. You can simply ask Japan. Japan has been struggling with deflation and has had bouts of deflation since the late 80s. Okay? But GDP equals P times Q. Remember, we're attempting to measure quantity, and we are now aware that prices of goods and services change over time. So what we need to do is we need to develop an efficient mechanism or methodology for accurately measuring changes in GDP over time, knowing that the price level does not remain the same or constant. How do we do this? Well, first of all, this is called real GDP, right? Economic output, which has been adjusted for inflation or changes in the price level, is referred to as real GDP. Okay? So the numbers on the previous slide, we can think about those as nominal GDP. Right? Nominal GDP means economic output which has not been adjusted for changes in the price level. Right? So here's what economists have done. Right? We know that the value of P changes. So what we need to do is we need to come up with some mechanism, some tool, some economic concept to put into a model to calculate in the most accurate possible manner actual economic output changes after taking into consideration that price level changes over time. So what we're going to do is we're going to employ the use of what's called a price index, which would treat prices as if they remain constant over periods of time. So in the next slide, we will investigate this idea of how we go about calculating real GDP using what's called a price index to accurately measure economic output over time. So nominal GDP. GDP which has not been adjusted for changes in the price level. Notice the word nominal and the word not both begin with N. Easy way to remember this. So it is also referred to as GDP reported at the prevailing year's prices. In other words, what was the price of goods and services in the year it was recorded or reported, right? Most of the time, though, economists are interested in real GDP, right, which is simply gross domestic product, which has been adjusted for changes in the price level. So we use, as I said on the previous slide, a price index. And in this case, we're going to use the GDP price index. The GDP price index, right? So after we have developed this price index, we can put it into this formula. Notice it says that the price index in a given year is the price of a market basket in a specific year in comparison to that highly similar or same basket of goods and services in the base year. So think of it in these terms. If we collected a basket of goods and services in, say, the year 2000, and we figured out, okay, how much does that basket of goods and services cost? If we want to accurately report economic output and changes in GDP over time, what we would have to do is we would have to report the quantity of output in terms of the price level of the base year. So assuming that the prices remain constant, in other words, prices of goods and services in all years prior to and after the base year were the same as the base year. In that manner, we can adjust for changes in the price level and accurately measure GDP over time. So if we know the price index and we know nominal GDP, we can use this straightforward, simple formula. We take the nominal GDP measured and reported at the prevailing year's prices, divided by the price index. One small caveat, make sure you see it says nominal GDP over the price index in hundredths. An exercise will help to clarify all of these thoughts. So, as I said earlier, we're going to use a little exercise to reinforce the idea and explain into much more detail the difference between nominal GDP and real GDP and the importance of using real GDP as the tool to calculate the changes in economic output or the changes in economic production over time. First, a quick review of the definitions. Nominal GDP. Economic output which has not been adjusted for changes in a price level. So GDP which has not been adjusted for changes in inflation. Now remember, we said that since 1950 the United States has had some level of inflation, some increase in the average price level of goods and services. So let's just take, say for instance, the year 1989. If we take the quantity of goods and services produced in that year times the prices of those same goods and services, that will give us nominal GDP. GDP reported in the prevailing year's price level. Real GDP, gross domestic product, which has been adjusted for changes in the price level. Real GDP is a much more accurate measure of changes in economic output over time because we introduced that equation that GDP equals P times Q. That's the way we calculate gross domestic product. But we all understand now that P, price level in the economy, changes over time. In order for us to accurately measure quantity of output and the changes in quantity of output over time, we need to adjust nominal GDP for those changes in the price level. The third line simply gives you the formula. How do we go about calculating real GDP? We take nominal GDP divided by what we call the price index in hundredths. So in a previous slide we explained the importance and understanding of a price index. Let's look at the data down below. Let's jump down to the year 2000. So in this particular exercise, the year 2000 is the base year. That's why nominal GDP and real GDP are equal. That's why they're the same number, 9,623,000,000,000 for both of these numbers. Now, economists can choose any year to be the base year. That part of the exercise is relatively simple. Any year can be dedicated to be the base year. And in the real world, the Bureau of Economic Analysis updates the base year every so often in an attempt to more accurately adjust for changes in the price level over time. Notice that in all years prior to the base year, the price index is less than 100. And that should make sense. It should be common sense to you, figuring that the prices of goods and services cost less as you go back in time. So obviously in 1994, the average price of goods and services cost less than they did in the year 2000. And notice the further you go back, the smaller the price index gets. So how do we calculate each of these real GDP numbers given our nominal GDP and our price index? And how do we determine if they are inflating or deflating? That's what we'll do on the next slide. Here are the exact same numbers for the years and nominal GDP and the price index as the previous slide. However, real GDP has been calculated, and it states for each year whether it has been inflated or deflated relative to the year, which is the price index. So let's start by reviewing the year 2000. In the year 2000, that is our base year. Economists chose this year to be our index. In other words, let's treat all years as if the prices of goods and services cost the same as if they did in the base year. That's the purpose of having a base year. So let's adjust economic output for changes in price level over time using this price index formula. The formula is up top. You simply take nominal GDP divided by the price index in hundredths. So if we look at the numbers, let's go through the math so you understand where we're getting the real GDP calculation. Let's start with 1964. In 1964, nominal GDP, gross domestic product, economic output, reported at the prevailing year's prices in 1964 was $663.6 billion. If we take 663.6 and divide that by 0.2213, because remember, we have to move the decimal point 2 places to the left because the formula calls us to divide nominal GDP by the price index in hundredths. 663.6 divided by 0.2213. Real GDP comes out to be $2,998.65 billion. Okay, so look what's happened. The real number is larger than the nominal number, which means we've inflated nominal GDP to get real GDP. Why is this taking place? Well, remember, 2000 was the base year. Goods and services most definitely cost more in the year 2000 than they did in 1964. So for us to accurately measure economic output in 1964, adjusting for changes in the price level, we inflate nominal GDP to get real GDP. And notice that's going to be true for all years prior to the base year. For every year prior to the base year, 64, 74, 84, and 94, the real GDP number is going to be larger than the nominal number. And that is because goods and services on average the prices were less in those years than they were in the base year. Notice that also over time, the adjustment gets less and less. In other words, the first adjustment was quite steep, 663 to 2998. But notice for 1974, 1500 divided by 0.3473, there's still a substantial adjustment to 4,319.03 billion. And then 84, there's some adjustment. And then look by 94, we're only adjusting nominal GDP of 7,072 billion to 7,835.15 billion. And that should make sense to you as well, is because the prices of goods and services were less in 1984 than they were in 2000, but there wasn't a dramatic or a drastic change in prices of goods and services over that 6-year period between 1994 and the base year. There was some level of inflation, but not a tremendous level of inflation. How about the year 2004? That year is after the base year. In that year, nominal GDP was 11,734.3 billion. If we take 11,734.3 divided by 1.09, we get 10,765.42 billion. So in 2004, real GDP is actually less than nominal GDP. And that should make sense to you as well, because between 2000 and 2004, the average prices of goods and services increased, and therefore the economy experienced some inflation. So we've adjusted nominal GDP in 2004 to reflect those changes in the price level, and real GDP calculates to 10,765.42 billion. GDP does a fine job of measuring the price of final goods and services times the quantity of those goods and services. It is a statistic. It is the most useful statistic for estimating the amount of economic activity which takes place in the United States each year. And every country within the World Trade Organization, the WTO, goes about calculating GDP with the same manner or same mechanism. However, like all statistics, GDP has its shortcomings. It's not really a perfect measure of the economic and financial well-being of citizens in a country. So let's go through some of these shortcomings. What does GDP fail to measure, or why is it not perfect when you talk about measuring standards of living in a country? The first shortcoming is what we call non-market activities. So assume that two people are married. The husband and the wife have 3 children. And the wife has a lucrative job, and the husband decides, you know what, I'm going to take time off during these formative years between the time my children are born and the time they are in full-time school. So let's call that kindergarten. Let's call that 6 years old. And I'm going to watch the children. So staying at home and watching children, that activity is not only demanding, it's something that a lot of people pay for. So a lot of people send their kids to daycare, or they pay someone to babysit their children. So if it's a market activity where it's recorded on the books, so to speak, right, it's counted towards GDP. So if you take your kids and you drop them off at ABC Learners preschool, and you drop them a check every month for, say, $1,200, that's counted towards GDP. But if the same activity takes place inside the home and is not reported because there's no market transaction, so if one of the parents or even one of the grandparents watches the children, it's a non-market activity. A similar idea would be if you were mechanically inclined and decided, you know what, I can tackle the job of refurbishing my kitchen. Right? I can do that manual labor. I can do the plumbing, the electric, the carpentry. Right? I can set the tile. I can set the countertop. So obviously, when you go down to Home Depot and you buy all the materials necessary for the kitchen remodeling, that would be counted towards GDP because that's a market activity. But you did not pay a contractor. You may have dropped 5 or 10 or 20 grand on a contractor, depending how big your kitchen is and how much, how involved the renovations would get. But it's a non-market activity, so it's not counted towards GDP. So non-market activities are one of the shortcomings of gross domestic product as a measurement tool of financial and economic activity and well-being. This next one, at leisure time. The average work week in the early 50s was somewhere near 50 hours a week, and that has declined to somewhere near 38 hours a week. So people have more time off. Likewise, people generally, especially people with college degrees, have more vacation weeks per year. So there's no real way to sort of manipulate that at leisure time into the GDP number. We know it exists, but it's one of the shortcomings of this statistic of gross domestic product as a measurement of economic activity. This is a big one, improved product quality. If you think about the cell phone that you own compared to the first cell phones that came out, right? Or think about a laptop that exists today versus a laptop from even 10 years ago, right? It's interesting when you think about the improvement in product quality. Let's stick with the example of a computer. In 1994, a desktop computer probably cost you $1,500, and the monitor probably cost you another $700, and the printer cost you another $300. So you're looking at dropping 15 plus 7 plus 3. That's $2,500 on computer equipment. That same basket of computing equipment today would probably cost you, I don't know, maybe far less, maybe close to $600. But the computer power has increased dramatically, and the sharpness of the monitor has increased substantially. So there's no way for the statisticians in the Bureau of Economic Analysis to add in improvements in product quality. The underground economy. Now this is the one that usually gets students excited to say, oh, good things like prostitution and the mob and drug activity. Well, we know those exist, and actually the Bureau of Economic Analysis does try to calculate how much of that takes place, but it's not yet counted in GDP. But what we're really interested in here is perfectly legal activities which are not reported. So for instance, let's say I own a restaurant, and let's say it's a breakfast luncheonette joint where I have a lot of people coming in from 6 a.m. to 2 p.m. I sell a lot of coffee, I do a lot of eggs in the morning, I do some sandwiches, I got a good gig going. Those type of going concerns, those type of businesses, oftentimes have requirements that people pay cash only. Now, I'm not accusing anyone of anything here, but oftentimes not all of that cash is reported. So it's a perfectly legal activity, but it's not reported, so it's a shortcoming of GDP. I'm sure you can think of many examples of underground economy where perfectly legitimate or legal economic activities are taking place, but they're not reported. Heck, think about people that offer their contractor a cash to finish a job in their home because they get a discount, right? So there's another example of what we would call the underground economy. GDP and the environment. This is an interesting one. So the Exxon Valdez and the BP oil spill in the Gulf Coast, those were mega environmental disasters. All of the money that was spent on attempting to clean up those environmental disasters was actually added into GDP, which sounds kind of crazy, but those environmental disasters actually increased the GDP numbers for those years. However, we do not subtract out the pollution and the environmental damage that we may be doing to the air and the water. So it's sort of a double-edged sword there, where we add in money spent on cleaning up environmental disasters, and we do not subtract out any of the money that environmental damage does to our world. Composition and distribution of output. What is this referring to? Well, when I was in school, when we did the production possibilities frontier, we would actually label one axis guns and the other axis butter. The United States spends roughly $600 billion on military outputs. That's a pretty big number, right? Guns and tanks and ships and planes and such. Even beyond military spending, what about things like video games, right? If you think about certain activities, certain services which are available, GDP is a statistic. If we looked closer at some of the goods we were consuming and the services that we were consuming as well, we might want to ask, are they doing any moral damage to society? Well, GDP is a number. It doesn't have any value-based judgment on people's habits or people's activities. Just something to think about. Non-economic sources of well-being. So, beyond the cold, hard facts of economic output, of goods and services produced, and economic production, and how much the economy has increased year over year, there are many other ways that people can, what we would say, experience happiness. Going for a walk on the beach, reading a book, right? And there's actually been what's referred to as the gross national happiness gauge. So building on the idea of non-economic sources of well-being, this idea of gross national happiness was introduced in the 1970s in Bhutan, which is a country near the Himalayas, a Buddhist country, which fostered the idea that human beings should not judge their well-being based on a number such as gross domestic product. So here are some other, we should say, parts of life to consider. How well we use our time, how much sleep do we get, what kind of education level does the average citizen achieve, and what do they know, right? How much cultural diversity and resilience does the average person in the country have? Do the people believe in their government? Do they think that their government is trustworthy? Right? Is there any community vitality? How much time do they spend with neighbors and friends, and is it safe to live there? Right? Ecological diversity. Are they respectful for the ecological systems within their nation? Like living standards, and how does the average person rank with the very wealthy, and how about the per capita income, which we will investigate on the next slide, and then psychological well-being, like how satisfied are you with your position in life. So this does have value. In other words, GDP isn't the end-all be-all of happiness and well-being for each person. So here are the world rankings of happiness for 2016. What goes into this score? Right? Per capita GDP. So if we take the economic output of a country and we divide it by the number of citizens, how much does the average person share in the economic activity, the economic production of that country? Social support. In other words, how much support do you feel from your surrounding society? Healthy life expectancy. Obviously, the longer you live, usually the better off you are. And this is a big one. Freedom to make choices. Right? That's probably why you don't see some countries on here, because they aren't free to make choices. The level of generosity in the country, and this is a big one. The level of trust. I'm sure it's trust in both your government and trust in your neighbors. Right? This last one, dystopia, it's sort of the opposite of utopia. In other words, utopia, everything perfect. Dystopia, everything in the country is bad. So you don't want a high level of dystopia. So in 2016, Norway, Denmark, Iceland, Switzerland, Finland, Netherlands, Canada, New Zealand, Australia, Sweden ranked in the top 10 of world happiness when you take all of those factors into consideration. The good old US of A, not too bad, right? We were ranked 14th, which overall it's not the worst ever. I like this because it also shows you where you've done or how you've done over the last year. If you look at the second column, it says change in score, and also on the right, on the left, it also says change in rank. So notice that Norway moved up 3, right? The United States moved down 1. I guess that's not the greatest, but I would guess that if you looked at these numbers for the next year, they would be quite similar. In other words, there wouldn't be too much jogging of positions within these countries, jostling of positions of these countries. But it's just something to think about. GDP is not the end all be all of happiness for the average person.